Hello all, welcome to Engineering Economy course. We are learning the time value of money and we are learning how to do present and future worth analysis using different type of payment series. In our previous lectures we learned the uniform payment series, and in today's lecture we will see another commonly used payment series which is called linear gradient payment series, and we will learn how to find its present, future or annual equivalent values. So let's get started. Sometimes the cash flows may increase. We may decide to, for example, make a loan payment by increasing our payments at each period by a constant amount. In these cases, since this case is also a common method used in the real practice, the factors and the formulas derived for this case as well. So instead of shifting all these cash flow payments to the present or future time one by one, we calculated or we developed a formula to identify the present and future value of such payments quickly and easily. And also there are factors for this case as well, like the uniform payment series, the factors that we use for uniform payment series. We also have the factors for this case. And this case, when the cash flows change by a constant amount, we call it uniform arithmetic gradient series of cash flows. And simply these cash flows has such a structure. At the end of year 1, the cash flow is 0. At the end of period 2, so I told it year, but it can be month, week, quarter, so it's better to call it a period. At the end of period 2, we increase the cash flow by a constant amount of G. So this G represents the amount of increase in the cash flow, or it can be decrease as well. Okay, in the third period, it is 2G, and it increases by an amount of G at each period. So if this is the case, we call it a uniform gradient cash flow, gradient series. So the structure of linear gradient series can be seen better in this cash flow diagram. As you can see, at the end of the first year, there is no cash flow, it is 0. So you may ask why it is 0, why it is not G, why it does not start from G. Actually, this formula is developed for this structure. And if it starts at G from the end of the first period, we can also incorporate it in the following examples. We will see how we can find present future values when we have the cash flow, when the cash flow starts from the end of the first period. And simply, actually, usually we don't start with a 0 payment. We start, let's say, a constant amount of payment, let's say 1,000 usually, 1,000, let's say, dollars of payment in the first period. Then we increase this amount by G, which can be, for example, 100. So it means that at the end of period 2, we pay 1,100. And then at the end of the third period, we pay 1,200. So at each period, we increase it by an amount of G. So the first payment is 1,000, which occurs at the end of the first period. And the increase starts from the second period. Okay, so that's why in order to calculate the present value of such a structure, we are assuming that the increase in the payment starts from the end of the second period. But it is very important that you memorize this structure, because one of the most common mistakes that the students do in the exams, in the questions, is this. When there is such a structure and when you want to find the present value of this structure, using this formula over here, they assume that they are finding the present value at this time. But unfortunately, this is wrong. The correct thing is, when you use this formula, you are finding the present value at this time. Okay, that's why it's important to memorize this structure. And this formula over here is developed for this structure that finds the present value when there is an increase in the cash flow. There is a change in the cash flow by an amount of G, and this first increase occurs at the end of year 2. And this is the factor representation of the same. Okay, so we read it as P given G, the amount of increase, interest rate, and the number of periods. And as you can see, number of periods is not the amount of increase, the number of times that we increase. It is the number of periods from the start of the payment series. So we use n here, not n minus 1. Okay, so pay attention to this factor, how we represent it. This is the formula. You just plug in the values of the interest rate and the number of periods here. And when you multiply this formula with the amount of increase, or this factor, you look up this for this factor in the factor table at the end of your engineering economy books. So when you look up this value and multiply it with the amount of increase, you will find the present value at time 0. Okay, it's very important. As I told you, we may have actually different situations. Usually we don't just start from a 0 payment at the end of the first period and just increase starting from the second period. Usually we start with an initial payment amount at the end of first period, and then we start increasing this by an amount of G at each period. Okay, so we need to find the present or future value corresponding to this payment. This is more common way of doing these payments in real life. Sometimes we have a different structure. We start with an initial payment. Instead of increasing this value at each period, we start decreasing this at each period. And now we are going to see how we can find the present or future values corresponding to these two cases. And actually these two cases are still linear gradient series, or we will make use of the linear gradient series formulas and factors to calculate the present or future values corresponding to these cash flows. Okay, let's have a look at the first alternative. So in the first alternative, what happens? At the end of the first year, we make a payment of a one amount. This can be, for example, 1,000, 5,000, a certain amount. And at the end of the second period, we increase this amount by G. At the end of the third period, we increase the previous amount again by G. So when you subtract one period, payment in one period, from the following, the difference is equal to G. And in order to find the present or future values of this one, we don't know the formula for this. Okay, the linear gradient series formula is not for this structure. You should memorize it. The formula is for this structure. So at the end of the first period, there's no payment. At the end of the second period, we have a payment of G, and it increases in each period. Okay. So what do? We need to convert this cash flow, for which we don't know the formula or factor, to maybe two or more cash flows for which we know the factor or we know a formula. And it's easy. For this case, we divide it into two different cash flows. The first one is a uniform payment series considering this A1 amount, and if you look, in all these cash flows, we have an A1 amount, okay? And it's a uniform payment series. And we say that this plus the remaining part in this is the amount of increase. And it starts from the second period, because the second payment here is A1 plus G, and when I subtract this A1 included in the first payment, first cash flow, for the second one, the remaining thing is G. And then we have 2G, 3G. Now, I know how to find the present or future value for this uniform payment series. And I know the formula to find the present or future values for this one. Then I can find their present values separately and just sum them up to obtain the present value of this one. Okay? The idea is to divide this cash flow into two known cash flows. The second one, for which there is a decreasing gradient series, we do the same thing. Okay? Again, we need to divide it into two cash flows for which we know the formula. And for this one, how can we do it? We assume that at each period there is an A1 amount of uniform payments. Okay? But this time, as you can see, at each period there is a decreased amount of G. So in the first period, we need to have A1 minus G. So, but we don't know the formula for a decreasing gradient series. We know the formula for an increasing gradient series. So for this reason, we just change this sign over here, and we say that this cash flow minus this increasing cash flow gives me this decreasing initial cash flow. And if you do this subtraction period by period, in the first period we have A1 minus 0, so that makes A1. For the second period, we have A1 minus G, which makes A1 minus G. And for the, let's say, last period, we have A1 minus 5G, which is A1 minus 5G. And now I know the formula or the factor for this one, and factor or formula for this one. I can calculate their, for example, present values separately and just subtract from each other to find the present value of this original cash flow. So an example will be helpful in understanding. It says that the initial amount is 1,000. So when you are given with such a problem, such a problem definition, the first thing should be to sketch the cash flow diagram. Okay? It says that the initial amount is 1,000, and G, the increase in the cash flow, is 250, N is equal to 5 years, and the interest rate is 12%. Find P. So the cash flow should be something like this. Okay? So initially, this is time 0. At time 1, we are making a payment of $1,000. And then in period 2, this amount is increased by $250. So it will be $1,250. In the third period, again it will increase and it will be 1,500. Fourth period, 1,750, and fifth period it will be $2,000. Okay, and this is the cash flow diagram. Now, how we can find the present value? Again, we don't know the formula. Some students do this mistake and assume that, okay, this is the linear series, gradient series, and they assume that this first one is the increase amount, or just ignore it and they say that, okay, the increase amount is 250, so they just try to find this P for this formula, saying that I need to multiply 250, which is the increase amount G, with P given G, I, and 5%, and 5 periods, and this I, the interest rate, is 12%. And of course this is not correct. Okay, we don't know the formula for this series. We need to convert it to cash flows for which we know the formula. And simply for this example, we will do this. At each period, starting from 1 up to 5, there will be a cash flow, constant cash flow of A1 equal to $1,000. And plus, on top of this, we will have a cash flow for this gradient series, which will start from period 2 with an amount of $250, and it will increase by $250 at each period until the fifth one, and it will be $1,000 in the fifth one. And for this one, I know the present value, which will be equal to A times P given A, 12% and 5. And for the second one, the present value, let me say this is P1, the present value of the first cash flow. And for the second one, the present value of the second cash flow will be 250, which is G, times P given G, 12% and 5 periods. And look, for this one, when I use this factor, I am finding its present value at time 0. Okay, not at time 1, at time 0. There will be no cash flows in the first period for a gradient series if you want to use this factor or formula. Then we will just add up P1 and P2 to find the final result. The present value will be equal to their summation. Okay, so this is the solution, how we do it. We will divide this cash flow into two separate cash flows. The first one is a uniform payment series, and we want to find its present value, plus the second part will be a linear gradient payment series, cash flow series, and we will find its present value, and then we will add up these two present values. And if you do the calculation, this factor over here is 3.6048, and the factor for the second part is 6.397, and the present value will be this much. Of course, you can use the Microsoft Excel to find the present value of this cash flow, and simply you can use this PV formula, the present value formula, to find the present value of each of these cash flows at the current time, one by one. In Excel, that's easy, and when you take its summation, you will find the same result. Okay, so by taking these cash flows at each period one by one to the present time using this formula, and then summing up their values will give you the present value of this cash flow. Okay, so sometimes we want to convert a gradient cash flow into a uniform cash flow or uniform payment series. And for this one, we also have a factor, and actually you can find this factor like this. This factor is equal to, first we can find the present value of a gradient series using this factor. Okay, so by this factor, if we have such a gradient payment series, we convert it to the present, and if we multiply this present value by this factor a given p, I and n, so this multiplication actually gives us this value. So in your, for example, books, look at the factor tables, and for each row select a table and the row and just multiply this value with this one, and you will obtain this value on the table. Okay, so this factor is called gradient to uniform payment series, and we simply want to do this. we have a gradient series and we want to convert it to such a uniform series starting from the first period till to the end. If you want to pay equal amounts instead of such increasing amounts, how much you need to pay? And for this, simply we will use this factor. In this example, assume G is given as 1000. So starting from the second period, we are increasing the payment by 1000 for 10 periods, and the interest rate is 12. So if you want to pay this in equal payments, how much you need to pay? So find this A. And for this one, simply we multiply the increase amount G with the factor A given G, 12% and 10, and we multiply this increase amount with this factor to obtain this result. So this is the equal payment amount if you want to pay with such a structure. And this is the formula for this conversion. Okay, this part is the formula. You just plug in the values of interest rate and the number of periods, and it will give you the factor, and the factor representation is this one. Okay, so let's solve an example problem for this gradient conversion. Let's assume that the end of year cash flows are expected to be $1,000 for the second year, and 2,000 for the third year, 3,000 for the fourth year, and it increases in this way. And the interest rate is 15% per year. Okay, so in part A, we want to find the present equivalent value at the beginning of the first year. As I told you, the first thing to do is to sketch the cash flow diagram. Okay, and in this cash flow diagram, it says that the first cash flow occurs, this EOY means end of year cash flows, and the first payment occurs at the end of second year. So this is year 1, this is year 2, and this is 1000. And in year 3 it is 2000, and in year 4 it is 3000, and it goes in this way. Okay, so I guess in this question there are only 4 periods. We don't have the rest, so just ignore this part. Okay, so we want to find the present value, and exactly look at this structure. It is just the gradient series. You don't need to convert anything. The initial amount is G, the second one is 2G, the third one is 3G, the first payment occurs at the end of year 2, and we want to find the the present value at time 0. And simply this present value will be equal to 1000 times P given G, and then interest is 15%, and the number of periods is 4. And look, there are 3 payments, but this number here is not the number of payments. Okay, it is the number of periods in this case, and it is 4. So by this way we can calculate the present value easily. And in part B it says that find the uniform annual equivalent value for this cash flow. So this is part A. Just look at this factor or plug in the values in the formula to find the result. And in part B we want to find A, and actually we can find this in different ways. The first way is this. So this increase amount multiplied by this factor A given G, 15% and 4. And this will give you this annual equivalent series. And the cash flow for this annual equivalent series will be this one. Starting from year 1, 2, 3, and 4, we will pay the same amount of A. Okay. Another method to find this is if you already find the present value by using this formula, this A can be found by P times A given P, 15%, and 4. So in the second one, what we did, we first converted this gradient series to present time, and then from this present time we converted it to annual series by this factor, and both of them will provide you exactly the same result, and this is the solution. So for the first part, when you multiply this factor with the gradient series, you can find this solution. For the second one, you can find the solution using this factor. Simply multiply this one by this and you will obtain this result. Or as I told you, instead of using this factor, you can use this present value that you find over here and just convert that value with this factor, A given P factor, and you will obtain exactly the same result with this one. Let's solve another example. So in this example, we want to find an equivalent payment series given an initial payment amount of A1 and an increase amount of G. So the story of the example is like this. We are making payments to a bank loan, for a bank loan, and we start by paying A1 at the end of first year, and starting from the second year we are increasing this payment amount by G, and the interest rate is given as 10% and the number of years is 6. So the first payment is 1000 and we are increasing this value by 300 each year. And how do we find the annual equivalent? Okay, so the first thing is to sketch the cash flow diagram. And for this cash flow diagram, I will sketch like this. So at the end of the first year, I am paying. Since I am paying, I will sketch this as a downward arrow, as a cash outflow, and I am paying $1,000. Okay. Then, starting from the second year, I am increasing this value by $300. And in the third year, I am increasing it again by $300, and I continue to do this by increasing $300 until the sixth period, end of the sixth period. Okay, so this is the cash flow diagram. What is this value? Actually, you don't need to know that value for your calculations, but you can write that value if you like. Also for the fourth period and the fifth period, you are going to increase these by an amount of 300 as well. So this will be $1,900, this will be $2,200, and this will be $2,500, okay, for the sixth year. How do we find the value of A? And again, as you can see, it doesn't matter if these arrows are downward or upward. So if the payment amount or the earning amount increases from one period to another, so if the structure is like this, the cash flow structure, okay, or if the cash flow structure is like this, then this is a gradient increasing series. Don't confuse this with the decreasing series. In a decreasing series, if you sketch the arrows upward, so it will be something like this. So this is a decreasing series. Or if we represent the earnings, then a decreasing series will be like this. Okay, so these are the decreasing series and these are the increasing series. And we know the formula for increasing series, whether it's upward or downward, it's not important. We know the formula for this. For the decreasing series, we need to divide this into two parts and represent it as a subtraction of an increasing series. Okay. So for this example, as you can see from the cash flow diagram, although these are cash outflows, okay, still this is an increasing series. It increases for each year, the amount of payment. But still we don't know the formula for this one, because in the first year there is an initial payment amount. So it means that I need to divide this into two cash flow series. In the first one, I will have this A1 amount, the same amount until year 6, which is 1000. And I will add the second cash flow starting from 0. And in the first period there is nothing. In the second period there will be a 300, and it will increase up to the 6th period by an amount of 1500. Now I know the formula for this one and I know the formula for this one to find the annual amount. Okay, for this first one, how do I convert this to a uniform payment series? Or do I need to convert it? Because it's already uniform. Okay, so it means that there's nothing to convert here. It will be just 1000 for each of the 6 periods, plus I need to convert this one into uniform payment series. And how do I do this? Let me name it as A2, and I need to use this factor, the increase amount 300. Then I want to find A given this increase amount G with an interest rate of 10% and number of periods 6. Okay, so when you use this factor, multiply it by 300, you will find the equal payment series for the second part, and when you add it to 1000, you will find the uniform payment series. So this is the solution for this question. The first one is already annual equivalent, plus the second one I need to convert this gradient into annual equivalent using this formula. And when we add this 1000 to this part, we obtain this. So it means that this one is equal to, economically equal to, this payment series up to period 6, 1, 2, 3, from 0. If you pay this equal amount of payment series, then this one is equal to this gradient payment series. Okay. Another example, so let's consider this cash flows at the end of each year. We have 5,600, 7,000, 8,000 payments for 4 years, and we want to calculate their present value with an interest rate of 15% per year. Okay, then in this example, look, we are not given what is G. We are not given what is A1. Remember, A1 is the first payment and G is the constant increase at each period. So how do we find it? Actually, we are not sure. Sometimes, in some cases, we may not be sure if it's a gradient increasing series or not. And in order to test it, what you need to do is you need to look at this difference between two consecutive cash flows. The difference here is 1000, the difference is here 1000, and the difference is 1000. And this difference is the same. It means that it's a linear gradient series, and G is equal to this 1000. Then what is A1? A1 is the first payment here, which is 5,000. And when you sketch the cash flow, it will be easier to understand. So at time 1, okay, the cash flow amount is 5,000, and then it is 6,000. Actually, this 6,000 is equal to 5,000 plus 1,000. So this is A1, this is G. And then we have 5,000 plus 2,000, which is A1 plus 2G. And we have this 8,000, which is 5,000 plus 3,000. Okay, and we want to find its present value, and simply we need to convert this into two payment series. One is an equal payment amount of 5,000. Okay, 1, 2, 3, 4 periods, plus the second one will be a gradient increase of 1000. and for the fourth we have 3000. And then we will find the present value of this one using 5000 multiplied by P given A 15% and 4 plus for the second one again we will need to find the present value, which is 1000 G P given G 15% and 4. Okay, when we add up these two values we find the present value. Okay, so this one is the original one. We divide it into two parts, for which the first one is the annual equivalent payment series, and the second one is a linear gradient series. And we identify the present value of the first one, present value of the second one, and add this up to find the present value of the original cash flow. So this is the solution. For the annual equivalent we use this factor, and for the linear gradient series we use this factor, and we obtain this solution, this present value. If you want to find the annual equivalent of the original cash flow, what we will do is, the first one over here, the first cash flow was already an annual value, equivalent value, so which is 5000, okay, uniform payment series. So we just need to convert the second part, the gradient series, into annual using this formula, this factor. And then when you add up this, you will obtain this result. But of course what you can do is, you can simply convert this, multiply this by A given P 15% and 4, and when you multiply that with this factor you will obtain this one. So you initially convert everything to present value and then convert this present value to annual equivalent payment series. Also you can convert this annual equivalent to present payment series simply multiplying this annual equivalent, this one, with this factor P given A 15% and 4. Okay, let's solve another example. In this case the cash flows does not increase, but they will decrease from one period to another. So it says that the initial payment at the end of year 1 is $1,1200, and this negative indicates that the amount of payment will decrease at each period by an amount of $200, and the number of periods is 5 years and the interest rate is 10%. Let's find the future value of this one. Okay, so the thing is, we first need to sketch the cash flow diagram, and let's do it. So assume that we have this initial cash flow at the end of year 1, then this cash flow is decreased by an amount of $200, so we have $1,000 at the end of year 2, and then $800 at the end of year 3, $600 at the end of year 4, and $400 at the end of year 5. Okay, the cash flow diagram is this, and we want to find the future value of this one. Okay, first of all, this is a gradient decreasing series, and for decreasing series we don't have a formula or factor. And secondly, even if it is increasing, until now we haven't learned a formula for future value. The formula and the factor that we used is only for present values, and if you look at the factor tables at the end of your book, you will not see such a factor. F given G, I and N. There is no such a factor. We have P given G, I and N, but there is no factor like this. What's the reason? Because when you have this factor P given G, I and N, you can simply multiply this by F given P, I and N, and this multiplication gives you this factor. So in order to not increase the size of the table, add more columns to this table, they just ignored this one. It is easy and more convenient to find the present or annual values. Okay, so for this example, first we need to convert this cash flow into a one which is an increasing gradient series, and then somehow we need to find the future cash flow. Let's do it. How can we convert this to two cash flows for which we know the formula or the factor? And as I explained before, the first cash flow will be a uniform payment series which will include this original one in all periods. Okay, for 5 periods we will have the same amount of payment, 1, 2, 3, 4 and 5. And from this one I am going to subtract this time. Okay, I will not add but subtract an increasing gradient series, and this will start from the end of year 2, and I will subtract 200 and then 400, 600 and 800 at the end of year 5. Now this is a uniform payment series and I can convert it to future time. This is a linear gradient series. I don't know the factor or the formula to convert it to future, but I can first convert it to present time or everything, and then take this present value to future time. Okay, so for the first one, in order to find, let me say this future value is f1, and for this the future value is f2. For the first one, the future value will be equal to 1200 times f given a, interest rate is 10% and the number of periods is 5. And for the second one, I will first convert it to present time, so it will be 200 p given g, 10% and 5, then multiply this by a factor to convert it to future time. It will be f given p, 10% and 5. Okay, and then the future value of the cash flow will be equal to f1 plus f2, the summation of these two future values. It will be the subtraction of these two values. It will be f1 minus f2. Okay, so the first one I converted using this factor, and the second one, first I find the present value and then convert it to future time, and then I subtract its value to find this one. Okay, so pay attention that we are subtracting this time, not increasing, not adding or summing. I told you that we don't have a formula for finding the future value or a factor, but in fact we can develop a formula to find the future value for a given g. We can use this formula. Okay, this is the formula, and here this formula is the amount of increase and this is the interest rate. For example, in the previous case, the amount of increase g was 200, and we divide this by the interest rate, which was 10%, and then with this one we multiply this factor. Okay, f given a, I percent and n. We know this factor and we know the formula for this factor as well, and from this one we subtract n, which was 5 in the previous example, times g, which was 200, and divided by the interest rate. Okay, so this is a formula that you can use, but you don't need to use this formula. You don't need to even learn this formula, because we know that future value, you can find the future value from a present value. When there is a gradient series, we can first find its present value and then convert it to future. Or similarly, we can first convert it to annual and then find its equivalent value in future. So this is how we find or how we do calculations with linear gradient series. In our next lecture, we will learn a different type of payment series, which we call geometric gradient series.